You're welcome to this video. So in the previous one, we successfully utilized the S3 native Terraform state locking feature, okay? And we successfully migrated our Terraform state file, which is local, to the remote backend in S3. In this video, we're going to start configuring our VPC and the component. But before we go into that, let me quickly show you the output.tf file still in the backend folder, right? So right here, I want to have a block where the name of my S3 bucket will be displayed. This is the template. So S3 bucket is the name of this block, and the value of this output is actually what I want to have displayed in the terminal. Okay, so the value is our S3 bucket name. I want the S3 bucket name to be displayed for me. And how do we add the value? It is simply by going to main.tf file, and this is the resource block we use for provisioning our S3 bucket. I'll just copy the resource name and the type, right? Just copy it, come to output.tf and paste it over here. Remove the double quotes and just add dots. Okay, come to the end and add dot again, and then add the ID. With this, be rest assured that you get the name of your S3 bucket displayed for you. So that's it for output.tf file, and let's now go over to VPC. Okay, so once I click on my module, everything I have in the module folder will display. So let's go to VPC. Okay, that is what we are interested in right now. So for VPC, just click on the main.tf file. We'd like to start configuring this, but before that, I would like to add my input variable to start with. So in here, I'll just add the variables that I want to have for this. Okay, it is actually very simple to create. I have videos in this channel where we started building this from the scratch, but we just want to save time as well. To add a variable, input variable, is actually very simple. Just type variable and give the variable a name. So because I'll be creating a VPC, I will definitely have a VPC CIDR, okay, or CIDR block. So that is why I just decided to name this VPC CIDR. The description is VPC CIDR block. So you can, just use your own naming convention here. The type is definitely a string, okay? And then I'll have public subnet CIDR, I'll have private subnet CIDR, availability zone, EKS cluster name, okay? So yes, this will be the variable. And now let's go over to main.tf file and add our first resource block for VPC. So here I'm going to paste the VPC template, and remember, you can always copy the template from the Terraform registry that I've shown you. So VPC configuration, over here I have my resource name and the resource type, okay, and you can always choose the name you want. You can always change this one to whatever you like, okay. For the CIDR block, this is actually where we'll be referencing the variable that we just added, okay. So the name of my variable is VPC CIDR, so I'll just use var.vpc CIDR, okay. And enable DNS hostname should be true. Enable DNS support is also true. For the tag, this is definitely where you need to tag, depending on what you're actually trying to achieve, okay? The project is EKS cluster, is what I've chosen to give the first tag value. For the second key and value, I want to use environment as the key, and the value should be, let me just use dev, right? If this is your prod environment, you need to add prod and stuff like that. So let's just go with these two tags, and this should create my VPC for me. So right now, let's start adding the components. So over here, let's create our public subnet, okay? So we'll have 3 public subnets and 3 private subnets, okay? So first of all, let's begin with public subnet, and this is the resource block. This is the resource name and the type, and here we are using a count loop, okay, because remember we are creating 3 public subnets, so we need to really use this count loop. And then in this bracket we need to define our variable for our CIDR for subnet. So I'll just add var dot okay, it's already displaying here. This is probably subnet CIDR, so I'll just select it. So it is displaying because we already have it defined in the input variable file. Okay, for the VPC ID, for you to get the VPC ID, just go to your VPC block and copy this. Okay, so this is how you get your VPC ID, and then add dot ID, right? For the CIDR block, this is where we define the range of IP addresses that will be in our subnet. So here, because we already defined CIDR block for our subnet as well in the input variable here, I'll just add var dot this. I'll just get rid of this s. Okay, so that is it for the availability zone. I'm just gonna add, there's a typo here. I'll remove this. Okay, and that will define our availability zone. We'll have 3 availability zones actually, okay, and this is where we'll be defining the value later. Until we get there, let's just keep building. Okay, so we'll have 3 availability zones just for because we really want to have a very highly available infrastructure. Just that you know, I have a tutorial where I've, from the scratch, I taught how to deploy a 3-tier architecture. So I actually explained VPC and the component very well. If you want to really learn all the nitty-gritty in VPC, subnet, route table, internet gateway, stuff like that, I'm going to link that in the description below. Okay, so you can actually get that, but we also want to save time here, and I'll try as much as possible to explain. So this for public subnet. Now we can go over, okay, so for map public IP on launch is set to true, so this will automatically assign a public IP address to instances. All right, for tags, this will be, so you just have to define the tag you want according to the environment you're working in. Okay, I will just add public subnets, and the tier should be public. So this is the key and the value that I want to have, so you can define yours, right? So let's go over to private subnet. Have for private subnet, okay, so we'll just do the same thing here just as we did for public subnet. I'll just have var dot, this time this is private subnet CIDR here. I'll select it. VPC ID, it is the same. For the CIDR block, I'll just remove so I'll add var dot private subnet CIDR. Remember, it's already defined in our variable.tf file. There's a typo, this s shouldn't be here. Great. Then for the availability zone, I will remove this typo here as well, then add, so let's reference the variable. Okay, so it is var dot availability zones. Okay, we are good. Every other thing is similar to what we have in the public, but here the tag we're having is private subnet. Okay, and then the tier is private. So this subnet is actually meant to hold internal resources like our private workload, maybe if we want to have a database, and also our worker nodes. Okay, any resource we don't want to expose to the public, this is where we host them. Okay, the next resource is internet gateway, and this is the template for it. So we have internet gateway, and this is the name I've chosen to give to, so you can change it to whatever you want. Okay, over here, I feel I should zoom this a little. Appearance, just zoom in. Okay, great. I hope the view will be better for you now. So for the internet gateway, you just need to define the name of your internet gateway and add the same VPC ID we've been using here, and that should be it. Okay, why do you need internet gateway? This is required to actually allow public traffic in and out of our public subnet. Okay, it will be attached to the VPC. That is why we are adding the VPC ID here. So going down, let's see the next resource we want to add. To add our elastic IP, so we'll be creating an elastic IP, okay? And this, all you need to do is to define the name of your elastic IP. My own is elastic IP dash NAT, okay? We're using the account loop here, and for inside the bracket I just need to add, define the variable for our public subnet CIDR, okay? So I'll just add var dots. I'll select public subnet CIDR here. The domain is VPC, okay? And that's it for elastic IP. So simple. The next block we need to have here is NAT gateway. Here you go, a NAT gateway for outbound internet access, okay? So private subnet can actually download packages and update without necessarily exposing themselves to the internet. So for the count parameter here, let's add var.public subnet. Please take note, we're using public subnet CIDR over here, okay? The allocation ID will be, so we are using elastic IP, okay, over here for the attachment. So we have the resource type here as AWS EIP dot EIP dash NAT, okay? So this is how it should be, okay? For the subnet ID, we are using the AWS subnet.public. This is how it should be. So just leave it this way. For the tag, you just use the tag you want to use, okay? I have defined mine here. All right, so going down, what is the next resource we need to have? Next is route table. So we'll be adding a public route table, okay? I'll just name it public, right, for simplicity's sake. The VPC ID is the same we've been using, and here we'll define the route, okay? I will just allow all outbound traffic by this definition here. The gateway ID is the internet gateway that we've created. So how do you get it? Just scroll up and get to the internet gateway resource block and just copy this, okay? So once you copy that, you come here and paste it and just use dot to, to demarcate it, and then add dot ID. This is how you get the value for your gateway ID, okay? So remember, route table, public route table allow us to have outbound traffic through the internet gateway. So we'll associate this with our, public subnets, all right? So we have private route table, okay? Actually, each private subnet will need a dedicated route table to help route traffic, actually outbound traffic, through the corresponding NAT gateway, okay? It will ensure that internal resources can access the internet without being publicly exposed. So here, for the count parameter, for the loop, I'm just going to define the, the private CIDR, private subnet CIDR. So referencing the variable, it is var.private subnet CIDR. The VPC ID is the same we've been using. And for the route here, yeah, this should accept from anywhere. For NAT gateway, remember to restrict this if this is production, okay? For NAT gateway ID, so how do we get this NAT gateway ID? You just have to come to where you define your NAT gateway and just get this. Just copy the resource name and the type, and then you come here and paste it, okay? So that is what I did, and yes, we're using the count loop, the count.index. Then for the tag, how do you get the tag? Okay, so you can just use the tag whatever you want according to your environment. This is what I've chosen to use for my tag. Now let's go into association, okay, route table association. So in this next step, we'll be associating each private subnet to its corresponding private route table that we've defined here, okay? So let me just add the template for that, and that is it here. So AWS route table association, and I'll just name this private, okay, because we want to associate the private one. Here I've already defined the private subnet CIDR, okay, referencing the input variable we have here. For the subnet ID, AWS subnet.private. Remember when I created my private subnet, this is it here. So this is how you can get yours. So just copy that stuff and add it here, okay. And using this, at the end of the day, just add .id. That's how you need. So all you need here when you get the template is to add this stuff here, okay. You may already have it though in the template. So for the route table ID, AWS route table.private, the same way we got the subnet ID. So just go to your private route table and copy this stuff, right? That is how we are getting the ID here. And you should be fine for the association. Now for the next one, let's associate the public subnet with our public route table. I'll just paste here. We may actually need to maybe do this one first, although it doesn't really matter, but just for clarity. So for this one, we're associating the public subnet with the public route table, okay. So here I've defined the public subnet side, the subnet ID. I've shown you how to get it. For the route table ID, you know, just for you to come to your route table, the public route table, and get it from here, okay. And the association is actually done. So just a recap, we define our block, our Terraform block for VPC, for our EKS, right? And then we are having 3 public subnets, okay. We'll be defining the values in terraform.tfvars because we don't want to start hard coding the subnet IPs here. And also we'll be having 3 private subnets. We'll also have internet gateway. We are creating elastic IP. For the internet gateway, it is here, and we're having a public route table and as well creating private route tables, okay. This is where we've done the association, and we're associating public route table to public subnets, creating here we're associating private subnet to private route tables. So I hope this is clear enough. For the output.tf file, inside here I'll have some blocks, okay. And what are we going to display? So VPC ID output is actually necessary, okay. It's essential for associating other resources within the VPC, so we need the output, okay. How do we get the value? Let's just go to where we define our block for VPC and copy this, right? So I'll just paste it here and then remove this, add dot. At the end, I'm just gonna add ID. So we'll get the VPC ID at the end of the day. For public subnet ID, we actually need this as well. So just use the same method to get your value and add it here, and yeah, and it will display all the IDs for the public subnets, okay. And yes, for the private subnet, it is using the same method. So this is the output we want to have at the end of the day. So that is it for VPC creation and the components for our EKS cluster. Now that we have this, in the next video we are going deep into configuring our EKS cluster. I hope you enjoyed this. See you in the next one.